Welcome to Study Loop.
So this problem is problem number 27.21. Okay, so we have a deuteron of mass 3.34 times 10 to the negative 27 kilograms. So I'm going to write down here mass of deuteron, that is 3.34 times 10 to the negative 27 kilogram. Okay, let me write down the problem number here, 27.21. Okay, so mass of the deuteron is 3.3734 times 10 to the negative 27 kilogram. And this is moving in a magnetic field of the magnitude 2.5 Tesla. Now, when a charged particle moves in magnetic field, it moves in a circle. In this case, we have the radius of the circle is given, which is r equals 6.96 millimeter. So I'm just going to write down 6.96 times 10 to the negative 3 meter. Okay. So from this information we have here, we first want to find the speed of the deuteron. Okay. So V equals what? So when a charged particle in magnetic field, when the charged particle moves in magnetic field, then the force is provided by the magnetic field, right? So the force of the magnetic field, which is BeV, has to be providing the necessary centripetal force, which is mdv squared over r, okay, radius of the circle. So from this information here, if you cancel out this two here, you will get V equals BER over MD. All right. So this, I'm going to write this down here. This value is going to be, we know the value of B, and E actually, I forgot to mention here, E actually is always, E has to be 1.6 times 10 to the negative 19 coulomb. It's always that. So from here, if you just plug in all the values here, you're going to be getting 8.33 times 10 to the 5 meter per second. This is V. Okay. This is what the value is. Now in part 2, we want to find the time taken for the deuteron to complete half the circumference. Okay, so let's go to next page here. So for part B here, we want to find time taken to complete half the rotation, half the circle. So if you know the definition of the time period is the ratio between the circumference of the circle and the velocity or speed of the particle. So in this case, the time taken is half the time period. So it's just going to be t equals pi r, which is half of the circumference of the circle, over speed of the deuteron. Okay, and you know the radius, which is 6.96 times 10 to the negative 3 meter, and the velocity is 8.33 times 10 to the 5 meter per second, which we got from the beginning. Now, this will give us 2.62 times 10 to the negative 8 second. Okay, 10 to the negative 8 seconds. Now, we have next one part, which is part C. We want to find out if we apply the electric field, we want to find out the potential difference that is needed to move in move a deuteron from rest to acquire that speed, which is 8.33 times 10 to the 5 meter per second that we got. So to do that, we're going to apply a potential difference, which is going to create the energy EV, and all the potential energy is going to be converted into kinetic energy. Okay, so potential energy created by the electric field has to be equal to the kinetic energy. So from here, you can see V, sorry, this is not this V. It has to be the capital V, okay? So this is V has to be equal to md V squared over twice E. And we know all the values for md, V squared, and E, and this should be able to give us 7242.46 volts.